Okay, this is our Hydrate lab. You have two tabs, one that says sample data and one that says Hydrate lab write up. So you can click into the Hydrate lab write up. We're going to scroll through. You can see that there's some sample calculations that need to be filled in a little more thoroughly. And there's some conclusion questions at the bottom. The very first page is going to give you all of the information that you need for rows 1, 2, 3, and 4, or really questions 1, 2, 3, and 4. A lot of these are data entry. So let's go back and get our sample data. You'll need to take a screenshot of what you see right here. I'll briefly show you why that is. But let me get my screenshot. Let me show you why we needed to take a screenshot. Any little change or adjustment will change what is in each of the cells. It's randomly generated data that allows each student to have their own version of the lab. But if I decide I'm going to start working from what's written right here, it says calcium chloride. That might stay the same, but let's go to the other page. If I click calcium chloride, it turns green. That's good. We head back, and now it says sodium sulfate, and all of the data has now changed. So you need to make sure you have some data that's locked in place. Let me go back to my original screenshot and take a look. The substance I actually have is magnesium sulfate, or Epsom salts, and it says that my crucible and lid have an overall total mass of 27.74 grams. The hydrated salt, which was added, these would be my Epsom salts or the magnesium sulfate crystals, added into the crucible and lid, had a total mass of 32.22 grams. After heating 3 times and waiting for the mass to maintain a steady constant mass, I get that my anhydrous salt left inside of the crucible is 29.81 grams. Remember, that includes the crucible. When I go to determine how much hydrated salt is there, I'll need to take the difference of 32.22 and the crucible and lid, which was 27.74 for me. You should use your own data. I get a sample size of 4.48 grams, and I currently have it set to give you sample sizes between 1.5 grams and 5 grams. To get the mass of the anhydrous salt, I'll take 29.81 and subtract the crucible and lid. This will leave me with 2.07 grams of salt left in the container. The amount of water lost that was boiled out, that was heated out, would be 2.41 grams, or the difference between my anhydrous salt and my hydrated salt. Now, in case people don't know what anhydrous means, I've gone ahead and provided you with number 8, which currently is not worth any points because it's identical to number 6. We're going to worry about percent composition later. We'll also worry about our mole ratio later. But I want to show you that all of that work is available to you and shown down here in the calculations. Obviously, garbage in gives us garbage out. So if you look at this one where it says 2.07, let me go up here and let me write something silly, like turkey. It immediately turns red, but down here it fills in turkey, as though that's what I meant to show. I'm going to put it back to the 2.07. If you keep on scrolling, you'll notice there are other calculations that are left to be done that don't have answers filled in, and that's because the blanks above are still blank. They haven't been filled in. Those are empty cells. If you want to learn how to do things, just read through the first sample calculation and then look at the one that doesn't have numbers in it to see what's missing. If we scroll down, we could go ahead and put an X into either one of these and see if it's too high or too low. We could also fill in a Y on each of these, and we should go ahead and read through them. Remember to follow your instructor's instructions when completing this. Realize that these point values might differ, and off to the side here is the reaction that's going on where we're dehydrating a hydrated salt. If you want to see it in action, go ahead and watch the YouTube video that's connected.